Now we'll start with another chapter, continuity. Let's see this. The question is f of x is equal to x cos x plus 3 tan x upon x square plus sin x, where x is not equal to 0, is equal to 4, where x is equal to 0. Discuss the continuity of the function. Now if you are clear with your limits concepts, continuity should be very simple. Just in case if you are not clear with your limits concept, I will just write all the formulas of limits on the right hand side of the board for your benefit, guys. You have 5 formulas in limits. First, limit of x tends to a, x raised to n minus a raised to n upon x minus a is na raised to n minus 1. Limit of x tends to 0, sin x upon x is equal to 1. Limit of x tends to 0, a raised to x minus 1 upon x is log a. Limit of x tends to 0, e raised to x minus 1 upon x is equal to 1. Limit of x tends to 0, 1 plus x raised to 1 upon x is equal to e. These are 5 formulas of limits that you had learned. Now, can you just recap those formulas once again, please? Remember, these are those 5 formulas. These are those 5 formulas. Let's see all of them one by one. Once these formulas are clear, we should be able to solve the sum. Now let's start with the sum. They give you f of x is x cos x plus 3 tan x upon x square plus sin x. Multiply both sides by limit of x tends to whatever it is given to you. X is not equal to 0, so you will multiply both sides by limit of x tends to 0. X cos x, limit of x tends to 0 both the sides. X cos x plus 3 tan x upon x square plus sin x. Now divide numerator and denominator by x. If I divide numerator and denominator by x, I will get limit of x tends to 0, x cos x upon x plus 3 tan x. Tan x can be written as sin x upon cos x upon x, x square upon x plus sin x upon x. The right hand side I have divided the numerator and denominator by x, right? X and x gets cancelled. Cos of 0 is 1 plus 3. Sin x upon x is 1. 1 upon cos of 0 is 1. I substituted the value, guys. X is 0, sin x upon x is 1. So answer is 1 plus 3 upon 1, which is 4. Now the extra thing that you have to do in continuity. Till here the sum was exactly the same as in limits. Here you will say that you just prove that limit of x tends to 0, f of x is 4. It is given to you in the sum that f of 0 is also equal to 4, as limit of f of x as x tends to 0 is f of 0, both the values are 4. Therefore the function is continuous at x is equal to 0. That's how you define whether a function is continuous or not. If it is continuous, limit of the given number should be equal to the given number. Right? Do we get this thing clear? Everyone's followed this? Let's move on to the next one, guys. Discuss continuity of f of x is 2 raised to x minus 1 the whole square upon tan x log 1 plus x for x is not equal to 0 is log 4 x is equal to 0. Right? You have to discuss the continuity at x is equal to 0. Fine. Let's see this. Let's start with the sum. F of x is 2 raised to x minus 1 the whole square upon tan x log 1 plus x. Multiply both sides by limit of x tends to 0. Limit of x tends to 0. 2 raised to x minus 1 the whole square upon tan x log 1 plus x. Divide numerator denominator by x square. Observe carefully how I do this. I already have 2 raised to x minus 1 the whole square upon tan x can be written as sin x upon cos x log 1 plus x. Divide the numerator by x. Since you are taking the square common, that means you have divided the numerator by x square. Divide the denominator by x square. 1x you will write here, 1x you will write here. Divide the numerator and denominator by x square. Limit of x tends to 0. This is 2 raised to x minus 1 upon x the whole square upon sin x upon x 1 upon cos x. Now whatever is the number before log goes up in the indice. Now 1 plus x will go up in the indice. So this will be log 1 plus x raised to 1 upon x. Now use your formulas. 2 raised to x minus 1 upon x. You will use limit of x tends to 0. A raised to x minus 1 upon x, which is nothing but log 2 the whole square. Sin x upon x is 1. 1 upon. Substitute the value of x as 0. Cos of 0 is 1. Log as it is. 1 plus x raised to 1 upon x is e. This is nothing but log 2 the whole square. We know that the value of log e is 1. Okay, so I need not write the denominator because it is 1. So I get that limit of f of x as x tends to 0 is log 2 the whole square. In the sum it is given to you that f of 0 is log 4, as these two are not the same. Log 2 the whole square and log 4 are not the same terms. So as limit of f of x as x tends to 0 is not equal to f of 0, therefore the function is discontinuous at x is equal to 0. Fine. Let's move on to the next sum, guys. F of x is equal to e raised to 5x minus e raised to 2x upon sin 3x for x is not equal to 0 is equal to 1 for x is equal to 0. You have to discuss the continuity at x is equal to 0. F of x is e raised to 5x minus e raised to 2x upon sin 3x. Multiply both sides by limit of x tends to 0. F of x is limit of x tends to 0 e raised to 5x minus e raised to 2x upon sin 3x. This can be written as limit of x tends to 0 e raised to 5x, subtract 1 e raised to 2x, add 1. I am subtracting 1, I am adding 1 upon sin 3x. This can be written as limit of x tends to 0 e raised to 5x minus 1. Take minus sign common between these two terms. So this is e raised to 2x minus 1 upon sin 3x. Divide the numerator by x and the denominator by x. I am dividing the numerator and denominator by x. This can be written as limit of x tends to 0 e raised to 5x minus 1, split the numerator, upon x minus e raised to 2x minus 1 upon x upon sine 3x upon x. Now the formula says that whatever is the number in the indice, the same number should be there in the denominator. The number in the indice is 5x. So you divide by 5, multiply by 5. Divide by 2, multiply by 2. Divide by 3, multiply by 3. Fine? Now, apply your formula. So this will be 5. E raised to x minus 1 upon x is 1. Minus 2 into 1 upon 3 into 1. This is 3 minus 3 upon 3. 5 minus 2 is 3. 3 upon 3 which is 1. Therefore, you found out that limit of f of x as x tends to 0 is 1. F of 0 is given to you 1 right in the beginning of the sum, as limit of f of x as x tends to 0 is f of 0. Therefore, I can say that the function is continuous at x is equal to 0. Fine? Let's move on ahead. F of x is equal to 5 raised to cos x minus 1 upon pi by 2 minus x for x is not equal to pi by 2 is equal to 2 log 5 for x is equal to pi by 2. Fine. Let's see this. Now, f of x is 5 raised to cos x minus 1 upon pi by 2 minus x. Multiply both sides by limit of x tends to pi by 2. Limit of x tends to pi by 2, f of x is limit of x tends to pi by 2, 5 raised to cos x minus 1 upon pi by 2 minus x. Fine. Now, as x does not tend to 0, you have to make it equal to 0. How do you make it equal to 0? You will say let x be equal to pi by 2 plus h. As x tends to pi by 2, h tends to 0. Leave the left hand side as it is, make the changes on the right hand side. So, limit of h tends to 0, 5 raised to cos pi by 2 plus h minus 1 upon pi by 2 minus pi by 2 plus h. This is limit of h tends to 0. Cos pi by 2 plus theta is nothing but minus sine theta. So this is 5 raised to minus sine x minus 1 upon minus h. This can be written as limit of h tends to 0, 5 raised to minus sine x minus 1 upon minus h. I'm just rearranging them. Divide numerator and denominator by minus sine x. I'm dividing by minus sine x, I'm multiplying by minus sine x. Minus and minus gets cancelled. Use your formula here. This is going to be nothing but log 5. Which formula did I use? A raised to x minus 1 upon x, log a. Sin x upon x is 1. So this you will get as log 5. So you have found out that limit of f of x as x tends to pi by 2 is log 5. And right in the beginning of the sum they will given you that f of 0 is 2 log 5. Right? This should be h, guys. This is going to be h involuntary movements. We're so used to writing x that we don't write h only. Okay, let's get back. The sum still remains the same. Wherever there is x, you will write h. So this is log 5 and this is 2 log 5. As limit of f of x as x tends to pi by 2 is not equal to f of 0, right? Therefore, the function is discontinuous at x is equal to pi by 2. Fine, do we get this? Let's move on ahead. F of x is equal to root of x plus 3 minus 2 upon x cube minus 1 for x is not equal to 1 is equal to 2 for x is equal to 1. You have to test the continuity at x is equal to 1. F of x is square root of x plus 3 minus 2 upon x cube minus 1. Multiply both sides by limit of x tends to 1. F of x is limit of x tends to 1 square root of x plus 3 minus 2 upon x cube minus 1. First thing I'm going to do is try to get rid of the square root sign. How do I get rid of the square root sign? By rationalizing both the sides. So this is going to be square root of x plus 3 plus 2 upon square root of x plus 3 plus 2. I'm rationalizing the numerator. This can be written as limit of x tends to 1. This is in the form a minus b, a plus b. So this is going to be a square minus b square. In the denominator you have x cube minus 1, which I can expand by using the formula a cube minus b cube, which is a minus b a square plus ab plus b square into square root of x plus 3 plus 2. Now this can be written as limit of x tends to 1. X plus 3 minus 4 is x minus 1 upon x minus 1 x square plus x plus 1 square root of x plus 3 plus 2. X minus 1 in the numerator and denominator cancel each other. Once you cancel in the numerator denominator, you can substitute the value. 1 square is 1 plus 1 plus 1 into square root of 1 plus 3 plus 2. So this is 1 upon 3, square root of 4 is 2, 2 plus 2 is 4, answer is 1 upon 12, right? So you have found out that limit of f of x as x tends to 1 is 1 upon 12. But in the sum they have given you that f of 1 is equal to 2 as limit of f of x as x tends to 1 is not equal to f of 1. Therefore, function is discontinuous at x is equal to 1. Fine, do we get this thing clear? Let's go on to the next sum, guys. Limit of f of x is equal to 10 raised to x plus 7 raised to x minus 14 raised to x minus 5 raised to x upon 1 minus cos x for x is not equal to 0 is equal to log 10 upon 7 for x is equal to 0. You got to test the continuity at x is equal to 0. F of x is 10 raised to x plus 7 raised to x minus 14 raised to x minus 5 raised to x upon 1 minus cos x. Multiply both sides by limit of x tends to 0. So this is going to be limit of x tends to 0. F of x is limit of x tends to 0. Rearrange and write them. 10 raised to x minus 5 raised to x minus 14 raised to x plus 7 raised to x upon 1 minus cos x. I have rearranged the terms. Now this can be written as limit of x tends to 0. 10 raised to x can be written as 2 raised to x into 5 raised to x. 10 is 2 into 5, so it should have been 2 into 5 the whole raised to x. A into b the whole raised to m is a raised to m into b raised to m. Guys, I'll just show you that. A into b the whole raised to m is nothing but a raised to m into b raised to m. That law of indices I'm using here. So by using that law of indices, I get 2 raised to x into 5 raised to x minus 5 raised to x. Similarly, 14 can be written as 7 raised to x into 2 raised to x plus 7 raised to x upon 1 minus cos x. Now to get rid of cos x, you have to rationalize the denominator so that you can convert it into sine. So I'm rationalizing this 1 plus cos x. I'm rationalizing the denominator. This can be written as limit of x tends to 0. Between these two terms I can take 5 raised to x common. So I'll get 2 raised to x minus 1. Between these two terms I can take 7 raised to x common. So I'll get 2 raised to x minus 1 into 1 plus cos x. 1 minus cos x, 1 plus cos x. 1 minus cos square x, which is nothing but sine square x. This is limit of x tends to 0. 5 raised to x minus 7 raised to x. 2 raised to x minus 1. 1 plus cos x upon sine square x. Common bracket is 2 raised to x minus 1. Uncommon bracket is 5 raised to x minus 7 raised to x. Now this can be written as limit of x tends to 0. 5 raised to x minus 1 minus 7 raised to x minus 1. What did I do here, guys? I subtracted 1 and minus into minus I added 1. I have subtracted 1, I have added 1, and this minus 7 raised to x, I have taken the minus sign common. This is 2 raised to x minus 1, 1 plus cos x upon sine square x. Divide the numerator by x square, divide the denominator by x square. 1x I will write here, 1x I will write here. That means I have divided the numerator by x square, divide the denominator by x square. This can be written as limit of x tends to 0, 5 raised to x minus 1 upon x. I am splitting the numerator. 7 raised to x minus 1 upon x. 2 raised to x minus 1 upon x. 1 plus cos x, and in the denominator you can take square term common, so this will be sin x upon x the whole square. This is going to be log 5 minus log 7 log 2. 1 plus cos of 0 is 1, which is 1 here. Sin theta upon theta is 1. Now this can be written as 1 plus 1 is 2 log 2 into log a minus log b is log a upon b, right? So this is going to be 2 log 2 into log 5 upon 7. So you found out that limit of f of x as x tends to 0 is 2 log 2 into log 5 upon 7. But in the sum they have given you that f of 0 is log 10 upon 7. You just continue the sum there. So you will say that limit of f of x as x tends to 0 is not equal to f of 0. Therefore, function is discontinuous at x is equal to 0. Last sum to finish this chapter. Let's see that, guys. f of x is equal to x square sine 1 upon x when x is not equal to 0 is equal to 1 when x is equal to 0. You have to discuss the continuity of the function. Now we know that sine of a function is always between -1 and +1. Sine of any function is always greater than -1 and less than 1. Multiply throughout by x square. Multiply by x square. So I'll get minus x square is less than x square sine 1 upon x is less than x square. Multiply by limit of x tends to 0. Minus x square is less than equal to limit of x tends to 0. X square sine 1 upon x is less than equal to limit of x tends to 0 x square. Right? Substitute the value. If I substitute x as 0, I'll get 0 is less than equal to limit of x tends to 0. X square sine 1 upon x is less than equal to 0. It is greater than 0, less than 0. Not possible. So the only possible solution I can have for this particular equation is when the value of x is equal to 0. That means I can therefore say limit of x tends to 0, x square sine 1 upon x is equal to 0. The number cannot simultaneously be greater than 0 and less than 0. The only possible alternative for this equation to be true is when it is equal to 0. Right? So, limit of x tends to 0, x square sine 1 upon x is nothing but f of x is 0. F of 1, f of 0 is given to you as 1 in the sum, as limit of f of x as x tends to 0 is not equal to f of 0. Therefore you can say that the function is discontinuous at x is equal to 0. Fine, do we get this in clear? This finishes this chapter. Let's stop here for the day. Thank you very much.